Great. So hi, I'm Pallavi, and I'll be presenting today on our ongoing work on user-friendly sequential decision-making for non-AI experts. Over the course of today, we've heard of a lot of systems, AI and ML systems that interact with people in various contexts, either when it comes to day-to-day tasks or high-stakes decision-makings. But regardless of the context, for an intelligent system to be used by or for people, it needs to operate in alignment with user expectations and desires. I've been working in the self-driving car domain, and I'll give an example of where such an expectation or desire might not be very obvious. If I'm driving on a road and the speed limit is 60 miles per hour and everyone around me slows down to 30 miles per hour, I would want my self-driving car to slow down as well, even though that's not strictly law-abiding. So how can we define these often hard to pin down expectations? One analogy that we can use is when we go to the optometrist. When I go to the optometrist, I know that my vision is bad and I need some corrective lenses, but I wouldn't know how to precisely state what it is that I need. However, when the optometrist shows me various lenses and gives me different options to choose between, I can identify something I need when I see it. And then at the end of the day, I walk out with a pair of glasses that works for me. In a similar way, we're interested in this question of interactive learning, or how we can leverage interactions with people in order to capture their needs, expectations, preferences, etc. One way of technically capturing these preferences and beliefs is through a reward function. And there do exist many techniques to learn these reward functions from people. I'll give an example of three primary ones here. The first is demonstrations. So in this screen capture from the driving car simulator, I can say, well, in this environment, there are two cars. I'm the red one, and there's a white one that's going about its way. What should I do on this road? And then I might say, well, I'll just drive in a straight line, like this arrow is indicating. Simply just continue about my business. I can ask for ratings. So in this case, I can generate a trajectory for the car and say, is this good or bad? And as the user, I might say, well, this is quite bad because I'm actually going off the road and I would prefer to stay on the road if possible. So let's give that a 0. Or I could ask for preferences. And then in this case, the user might actually say, well, I actually prefer the one on the left because while I'm going off the road, at least I'm going forward. So there's a large body of work when it comes to asking for these types of demonstration questions or ratings questions or preference questions around how to ask good questions, when to ask questions, what the best kinds of questions are to ask. Our key insight is that we can actually combine multiple learning techniques to achieve faster convergence while minimizing human cognitive effort. If we look at demonstrations, ratings, and preferences, we can actually see that they lie along a spectrum from difficult to provide but very informative. For example, demonstrations are super informative. They tell us a lot about what a person might want, but they're very hard to provide. It requires a lot of energy from a person. And in some cases, depending on the person's capabilities or limitations, they may not be able to provide a demonstration that truly represents the behavior they want to see. On the other end, preferences are very easy to provide because you simply have to choose between options, but they're mostly good for fine-tuning and don't necessarily give a good global picture of what's going on. So each of these approaches to learning from a person is valid and valuable at various stages in the learning process. And when we look at how people learn, we see that people don't ask the same type of question over and over again. If I'm learning to cook, I'm not only going to ask for demonstrations forever. I'll also ask people if my cooking is good. So in the same way, we're hoping to create this dynamic system that can intelligently understand when to ask what type of question in order to make the learning process easier for people. I have this diagram here that kind of shows what the system looks like. The beige area is the training phase, and you can see that it's comprised of three distinct chunks, right? The demonstrations, ratings, and preference type questions. And we can dynamically or iteratively choose between these, leading to a final product on the other side that we can then decide whether that's good or bad. And we envision that the system might be really useful when it comes to enabling stakeholders to interact with the system. For example, in the self-driving car domain, some stakeholders include policymakers who might have needs around vehicle behavior, particularly when it comes to safety, product managers who may have desires around what the personality of the product should be, like the feeling it should convey, And then a rider such as myself, who I might say, well, I get really motion sick and I really don't want to get into a car that backs too aggressively. And none of those stakeholders necessarily has the ability to directly interact with the system as of now, right? But their needs are super important in order for this to become a product that's realized to the masses. And more generally, I'm really interested in understanding where else such interactive learning systems might be useful, and also in understanding what other techniques people are using to achieve inclusivity in designing AI and ML systems. So my email address is here. Please do reach out to me. I'd love to talk more. Thank you.